Bearings. Friends, look at the plane. If the pilot does not check on the compass and then bearing in that, then maybe the passengers may not reach at the right destination, guys. Whenever you are enjoying your holiday in a wonderful cruise, and we can see like in that cruise, every side you see and there's water, but still captain managed to find out the right directions because he has a good understanding of bearing, guys. Hello friends, in this video we will learn what is bearing and how to find out bearing in all different scenarios. Then we will learn how to find out switch bearing, and I will also give you one amazing golden principle for the same. At last we will solve two bearing word problems with increased challenge level. Watch till end to learn and master the concept of bearing. Now we'll try to learn how to find out the bearing in all different situations. So here, as you can see in the picture, how to find out the bearing of line 1, 2, 3, 4, 5, 6, 7 and 8. By the time you will learn how to find out the bearing of all different lines, you will master this concept. But before we will get into this, I want to teach you that true bearing is an angle from north axis in a clockwise direction. Bearing is an angle from north axis in a clockwise direction. At first, we will try to understand what is the bearing of my east direction, south direction and west direction, because they'll be acting as a reference angle. So let us say if I'm talking about my east direction first. So again, my bearing is an angle from north axis in a clockwise directions. And if I'm talking about east direction, when I'm making an angle from north axis in a clockwise direction, my angle is going to be 90 degree. So if it is a east direction, then my true bearing is 90 degree. Now let us think about the south, which is directly under the north. Then if I make an angle from north axis in a clockwise direction, my angle is going to be 180 degree. So it's very important to be clear about these reference angles. Now I'll be thinking about, let us say, west side. So if I'm making an angle from north axis all the way in a clockwise direction to the west, that angle is going to be 270. And let us say if I make the full round north to north, that is going to be 360. So 90 degree, 180, 270 and 360. That will serve as a reference angle to find out the bearing of different parts. Now we will try to find out the bearing of line 1, 2, 3, 4, 5, 6, 7, 8. Let's focus on line 1 first. So in line 1, the angle is 20 degree given with the north. Now the bearing is angle from north axis in a clockwise direction. Angle from north axis in a clockwise direction. So actually in this case, the 20 degree itself is going to be the bearing of line number 1. Now if I focus on line number 2, the 10 degree angle is given, but that is the angle given with the east side. Whenever I want to find out the bearing of line number 2, I got to consider about angle from north axis in a clockwise direction. Angle from north axis in a clockwise direction. Now north to east is 90 degree. And then I do have 10 degree less in that. So 90 minus 10. So that is going to be my 80 degrees. So the bearing of line 2 is 80 degree. Now we will focus on line 3 and 4. Whenever we want to find out the bearing of line 3, we'll think about the angle from north axis all the way up to line 3. So at first we can think about north to east. North to east is 90 degree. And then I go to plus 25 more. So 90 plus 25, which will make 115 degree. So my bearing of line 3 is 115 degree. If I now find out the bearing of line 4, I'll be taking 180 degree as a reference angle. So from north all the way to south is 180. But I do have 15 degree less in there. So the bearing of line 4 will be 180 minus 15, which will be 165 degree. Now we'll try to find out the bearing of line 5. So line 5 from north axis again in a clockwise directions. So we can say north to south is 180 and then 12 degree more. So 180 plus 12, which will be 192 degree. Now think about 6, guys. What will be the bearing of line 6? Now you got it, yeah? North to west is 270. But again, if I'm going in a clockwise direction, I'm 10 degree less. So 270 minus 10, that will give me 260 degree bearing. If I now find out bearing of line 7, I have to go from north to west, which is 270 plus 14 degree more. 270 plus 14 degree more. So 217 plus 14 will be 284 degree. And the last one, the bearing of line 8. So let us say if I go north to north, which is a full cycle, which is 360 degree. But if I want to go only up to 8, I got to go 30 degree less. So 360 minus 30, which will give me 330 degree bearing for line 8. Now friends, we will learn how to switch bearing. Many students find it very confusing. So please kindly try to follow it very step by step, and that is going to be very, very clear for you. So let us say the first thing given is bearing of B from A is 40 degree. So at first, we will learn how to read it correctly. Oh, correctly? Yes. Because I don't want you guys to read like bearing of B from A is 40 degree. I want you guys to read in this way. Bearing of B from A is 40 degree. It sounds funny, isn't it? It is actually, but it will help you like anything, guys. So definitely do it. Bearing of B from A is 40 degree. Why am I saying from A loud? Because from A, very important. That's where your north axis will go. So wherever there is a from, you got to be loud. You don't need to like shout really. You can be loud in your mind, but it's very, very important you become loud. So that's where your north axis will go. So bearing of B from A is 40 degree. So I'm going to make my north axis at A because it's from A. So north axis at A. And then I'll make a 40 degree angle with the north axis, and that's where my point B is. Now we will try to switch the bearing and we will try to find out what is the bearing of A from B. When I'm saying from B, I'm going to make my north axis at B, and then in a clockwise direction I will keep going till my A goes. And now from north to south, if you look from north to south, this is 180 degree, and then I do have little extra angle. To find out that little extra angle, I can look at 40 degree and little extra angle, and they both are alternate angles. Because they're alternate angles, they both are equal. So my bearing of A from B is going to be 180 plus 40, which will be 220 degree. We will consider second scenario to understand switch bearing properly. So let us say bearing of B from A is 240 degree. As we said, from A, at A, I'm going to make my north axis. And then in a clockwise direction, I'll make 240 degree angle, and that's the direction my point B will go. Now, we will try to switch the bearing. So we will try to find out what is the bearing of A from B. From B. Because it is from B, I'll be making my north axis at B. And then in clockwise direction, I will try to keep going till my A. Now, looking at the original diagram, that was 240 degree. So there was a 180 till south and 60 degree more. That 60 degree, I can see that is the angle with my north axis. So the bearing of A from B is going to be 60 degree. Now friends, I'm going to give you the golden rule for switching the bearings. But don't tell your friends, huh? Only for you. So let us say if your original bearing is less than 180 degree, then you can plus 180 to get your switch bearing. And if your original bearing is more than 180 degree, then you can minus 180 degree to get your switch bearing. How is that, guys? Very simple, yeah? But only a little secret, not to your friends, please. Tell me, friends, if bearing of B from A is 50 degree, then what is the bearing of A from B? What did you say? Oh yeah, that's correct. Less than 180. So you can do 50 plus 180, which is 230 degree. Absolutely correct. Another question, guys. If your bearing of B from A is 200 degree, then what is the bearing of A from B? What did you say? Oh, yeah, that's correct. More than 180. So you can minus 180, isn't it? 200 minus 180, which is 20 degree. Now we will try to solve word problems involved in the bearings, guys. This is going to be really important and exciting. So let us say word problem 1 we are going to solve, in which there is a ship travels south for 5 kilometer and then on a bearing of 120 degree for 11 kilometer. So two parts I got to figure out. Part number A is how far east the ship is from its starting point, correct, to two decimal places. And B part is find how far south the ship is from its starting point. Very first part is whatever is the data given, we will try to make a diagram with that. So let's make our north and south, east and west axis, and the origin is a starting point. So from starting point, at first ship is going 5 kilometer to the south. So from the starting point, we can make a line which is going 5 kilometer down, and then 120 degree bearing 11 kilometer. Now bearing is always from north axis in a clockwise direction. So if it is a 90 degree towards east, but 120 little bit further than east, so we can make a line of 11 kilometer on a bearing of 120. So that is a sort of our diagram. Now we want to solve a couple of things, so we'll try to make our little triangle so we can use our Sohcahtoa principle. So here with my second line, which is 11 kilometer, I'm going to make one horizontal line and one vertical line, so I can have my right angle triangle. Now in that right angle triangle, the horizontal distance I'm going to say x, and the vertical distance I'm going to say y. At the same time, we do know like the bearing is 120 and bearing from north to east is 90. So 120 minus 90, that is 30 degree. That is going to be my angle of the right angle triangle. Now let us see. At first, I want to find out my x. So I will not focus on y. I will just focus on x, because they are saying how far east the ship traveled from the original position, which is exactly x. So to find out x, I'm going to label my side. So the side which is opposite to the right angle is 11. So I will label that h, which is hypotenuse. And the side x is my adjacent. So I will put a next to that. Now a and h. So I've got a three principle: soh, kah, and toa. To pick up the right one, I'll think about ah. So that comes in kah. So I'll be using kah, which is cos theta equal to adjacent upon hypotenuse, which is cos 30 equal to adjacent upon hypotenuse, which is cos 30 equal to x over 11. So my x is going to be 11 multiplied by cos 30. You can put down then in a calculator nicely 11 multiplied by cos 30, which is coming 9.53, which 2 decimal places. So SIP is 9.53 kilometer east of its initial position. Now we will try to find out y in our right angle triangle. So we will try to neglect x for time being because we already found it. So my y is opposite side because that is the opposite to the angle, and 11 is the hypotenuse. So now O and H, O and H. So am I going to use so, ka or towa? Because I do have O and H, I'm going to pick so, which is sine 30 equal to opposite upon hypotenuse. So sine 30 equal to y over 11. So my y equal to 11 multiplied by sine 30. So my y equal to, whenever you put down in a calculator, guys, like 11 multiplied by sine 30, you're going to get 5.5. So distance in south. So distance in south is not just 5.5, because already like ship travel like 5 in the starting, like 5 kilometer in the south direction, and this is 5.5 further. So right from the starting, if you want to see how much distance travel in the south direction, it's going to be 5.5 plus 5, which is going to be 10.5 kilometer from the starting position. Now we'll look at the second word problem based on bearing. This word problem is a bit more challenging than the first one, but after learning this question, you will truly master the concept. So second question is, an aeroplane flies 138 kilometers in a southerly direction from a military airbase to a drop-off point. The drop-off point is 83 kilometers west of the airbase. Then find the bearing correct to nearest degree of the drop-off point from the airbase, and find the bearing of the airbase from the drop-off point. Now, one of the most important tasks is to put down these details into the diagram. So we'll try to understand, guys. They are saying an aeroplane flies 138 kilometers in a southerly direction. First thing what we got to understand is southerly direction is not like a south. It can be somewhere in like southwest or southeast as well. So I'm going to figure out, is it like in a southwest some direction or southeast? But they gave us a clue, like my drop-off point is 83 kilometers west of the airbase. So that is giving us a clear idea that it's like a southwest direction. So somewhere in southwest directions, I can make a line, start from the military airbase. So military airbase is the starting point because that's where my plane is taking off, and drop-off point is my destination. So I'm going to make one line in southwest directions from military airbase to drop-off point. Now I can try to make my little triangle because I do know my drop-off point is 83 kilometers west of military airbase. So that horizontal line is going to be 83. And the distance traveled by a plane is 138 kilometers. So this slant line or the hypotenuse of the triangle is going to be 138. Now I'm going to make my one angle, small angle, and that angle is going to be with the west direction. And that angle, I don't know. So I'm going to tell like this angle is theta. And that angle I'm going to find out, because once I have that angle, my first thing I want to find out is what is the bearing of drop-off point from military base. So when I'm saying from military air base, I got to make my north axis at military air base, and I got to find my angle from north directions in a clockwise direction. So now here, in case if I have got this angle theta, I can simply do 270 minus that angle theta, and that is my answer of the required bearing. So I'm going to just figure out my angle theta. Now in this right angle triangle, I'm going to use my SOHCAHTOA, but before I use that, I'm going to label the sides. So 138 is opposite to the right angle, so that is hypotenuse, and 83 is adjacent to the theta, so that is my adjacent. I do have A and H, so am I going to use like so ka or toa, because A and H, I'll be using ka. So I can put down ka, which is cos theta equal to adjacent upon hypotenuse. So cos theta equal to 83 upon 138. Now, whenever you want to get your theta, what you do is you do cos inverse. So now we will do cos inverse 83 upon 138. So theta is going to be 53 degree, and your required bearing, which is from north axis all the way to that airbase, is going to be 270 minus 53 degree, which is 217 degree. Now in B part, what they are asking is nothing else but the switch bearing, which we have already learnt. So I don't want to go in a longer way, because I taught you the golden principle. My original bearing is 217 degree, which is bigger than 180. So to get that switch bearing, what can I do is I can simply do like 217 degree minus 180, which is going to be 37 degree. That's so easy, isn't it? With our golden principle. Cool. So now, guys, you have truly mastered the concept of bearing. But I do understand this is a little bit challenging. So if required, go over this like 1 or 2 times and master this concept, guys. And if you like it, subscribe to the channel to enjoy more maths videos and to have a feeling that if you learn step by step, maths can't be hard, guys.